Look at the phone in your hand right now. You can feel the glass, the weight, the solidness of it. You think your skin is actually touching that screen, don't you? Wrong. You aren't touching it. In fact, you have never really touched anything in your entire life. There is a powerful, invisible force hovering just above your skin, pushing back, preventing true contact. And that invisible force? It is the exact same mystery that makes a magnet work. Welcome to the real world. You hold two magnets, you bring them close, and you feel that push. It's strong, it's real. And naturally, you ask, why? When you ask a physicist that question, they might tell you it's like a rubber band snapping back or a spring pushing out. That sounds reasonable. You know what a rubber band is. You've seen springs. You nod your head and think you understand, but you don't. Because you have to ask, why does the rubber band snap back? If you look closely at that rubber band, it's just a bunch of atoms holding hands, clinging to each other. And what is that clinging? It is electrical force. It is the exact same force as the magnet. So, do you see the trap? You cannot explain the magnet by comparing it to the rubber band because the rubber band is the magnet in disguise. You are using one mystery to explain the exact same mystery. Now we are cheating. To really understand this, we have to stop looking for things that are familiar. There are no ropes, no pulleys, and no gears down here. We have hit the bedrock of reality. This force doesn't look like anything else you know, because it is the foundation that everything else you know is built upon. So we have to accept it as it is, pure, naked force. You don't have to look far to find this force. In fact, you are sitting on it right now. Think about that. Gravity is pulling you down right now, trying to drag you right through the floor to the center of the earth. But you don't go through. You stay put. Why? It is because of the electrons in the seat of your pants and the electrons in the chair. They are repelling each other. They get close, closer, closer, and then they push back with tremendous power. They refuse to occupy the same space. When you push your finger against a table and you say, "Oh, that's hard, that's solid," what you are really feeling is that electrical force fighting back. It is invisible, but it is strong enough to fight the entire Earth's gravity. So a magnet isn't doing anything strange, and it is just a concentrated version of the force that keeps you from falling through the floor every single moment of your life. But how does it actually happen? That is the deep question. If I hold a magnet here and another one over there, there is space between them, empty space. How does this magnet know the other one is there to push it? Does it have eyes? Does it smell the other one? It seems like magic. It looks like action at a distance. But in physics, there is no magic. There is always a mechanism. Down at the bottom, deep in the quantum world, those electrons are not just sitting still. They are busy. They are constantly exchanging particles. We call them virtual photons. Think of them as invisible messengers. Imagine two people standing on a frozen lake, wearing very slippery ice skates. They are standing perfectly still. Now, imagine one of them holds a heavy basketball. He throws it to the other person. To throw it, he has to push the ball, and that push sends him sliding backward. The other person catches the ball, and the impact knocks him backward too. They fly apart. Now, imagine you are watching this from a mile away, and you cannot see the ball. It's too small, too fast. You just see two people suddenly sliding away from each other. You would look at that and say, "Aha, there is a repulsive force between them." But there is no mysterious force. The force is the exchange. That is what is happening inside the magnet. It is happening between the electrons in your finger and the electrons in the table. It looks like nothing is there, but the empty space is alive. It is a storm of these ghost particles zipping back and forth, creating the solid world you feel out of thin air. There are no gears, No wheels and no rubber bands. Just this frantic, silent game of catch. So, if this force is everywhere, if every atom has these spinning electrons, here is the obvious question. Why isn't everything a magnet? Why doesn't a piece of wood stick to your refrigerator? Why doesn't a copper wire grab onto a steel beam? The answer is not about power. It is about order. Every electron is a tiny magnet. In a piece of wood or copper, those electrons are spinning, but they are a mess. They are like a crowd of people in a busy city square, walking in every direction at once. One goes left, one goes right. One points up, one points down. They cancel each other out. All that power is there, but it is wasted in the chaos. The net result is zero. But in a magnet, something beautiful happens. The electrons stop jiggling randomly. They line up. They all face the same way. It is no longer a disorganized crowd, and it is a disciplined army marching in perfect step. When they all spin together, the effect doesn't just add up, it amplifies. One tiny electron is weak, but billions of trillions of them, all shouting in the same direction. That is a force you can feel. The magnet doesn't create the power. It just organizes the chaos. Look at this. A simple paperclip sitting on the table. Gravity is pulling it down. The entire Earth, all the mountains, the oceans, the molten core, that massive planetary weight, is holding this little clip down. Now, I take this tiny magnet, smaller than my fingernail, and I bring it close. Snap. It jumps up. Do you realize what just happened? This little piece of metal just defeated the entire planet. That is how weak gravity is. That is how terrifyingly strong the electrical force is. How strong? It is not 10 times stronger. It is not 1,000,000 times stronger. It is a 1 followed by 40 zeros stronger. That is a number so big, we don't even have a name for it. So why don't you feel it? If this force is a monster, why aren't you being ripped apart right now? Because it is perfectly balanced. The positives and negatives are mixed so thoroughly that they cancel each other out completely. You're safe because the balance is perfect. But if you disturb that balance even a tiny bit, just by rubbing a comb through your hair, you scrape off a few electrons and suddenly, boom. You see the sparks. You see the hair stand up. That is the monster waking up. That is the true strength of the universe, hiding inside a comb. Now, you might think this is all just theory. You might think it is just some scribbles on a chalkboard that physicists make up to feel smart. But it isn't. We have a map for this territory. We call it quantum electrodynamics, or QED. And it is not just a good theory. It is the jewel of physics. It is the most precise description of reality human beings have ever created. How precise? Let me give you an idea. Imagine you calculated the distance from New York to Los Angeles. That is nearly 3,000 miles. Then, you went out and measured it, inch by inch, all the way across the continent. The difference between what the theory predicts and what you actually measure would be less than the thickness of a single human hair. That is how well we understand this. It isn't a guess. It isn't a rough idea. We know exactly how those electrons dance, down to the tiniest, most impossible fraction. And that perfect, precise dance is exactly what snaps those magnets together. When you look at the world around you, the complexity of a forest, the chemistry of your blood, the firing of neurons in your brain, it looks infinite. It looks impossible to understand. How could a few particles create something as complicated as a human being? But the beauty of physics is that when you peel back the layers, the complexity vanishes. Deep down, the universe is not complicated. It is shockingly simple. According to this theory, almost everything you see, touch, and experience is made of just 3 simple actions. 3 little tricks. Action number 1. A photon goes from one place to another. Action number 2. An electron goes from one place to another. Action number 3. An electron emits or absorbs a photon. That is it. That is the whole show. There are no other hidden rules. Chemistry is just those 3 actions played out in a loop. Biology is just those 3 actions. The light entering your eye right now? That is action number 3. The signal traveling to your brain to tell you what you are seeing? That is action number 2. The magnet sticking to the fridge? That is a combination of all of them. It is staggering to think about. We are not built of magic. We are built of these 3 simple rules, repeated billions and billions of times, creating a tapestry so rich and complex that it can look back at the universe and wonder how it all works. Simplicity is the ultimate sophistication, but even with all this precision, there is a ghost in the machine. A single number that stares back at us from the blackboard, mocking our understanding. It is approximately 1/137. We call it the fine structure constant. It is the number that decides exactly how strong the electromagnetic force is. It decides how tightly an electron holds onto an atom. It is the dial that controls the strength of every chemical bond in your body. And here is the problem. We have absolutely no idea where it comes from. Why is it 137? Why isn't it 138? Why isn't it 50? In mathematics, you can usually figure out why pi is 3.14. You can see the geometry. But 137? It doesn't come from the math. It just appears. It is an arbitrary input. And if this number was different, if it were just a little bit bigger or a little bit smaller, the universe would be a graveyard. Atoms wouldn't form. Stars wouldn't ignite. Carbon wouldn't bond to create life. You wouldn't be here to ask the question. It is as if the universe is tuned, with terrifying precision, to that specific frequency. Some people look at this number and see the signature of a creator. Others look at it and see the parameters of a computer simulation, a hard-coded value set by a programmer. Feynman himself called it one of the greatest damn mysteries of physics. It is a magic number that comes to us with no understanding. It is just there, written on the fabric of reality, waiting for us to read it. So, look at the fire again. Really look at it. What are you seeing? You are seeing the sun. Think about the wood for a moment. Where did it come from? Most people think trees grow out of the ground, but they don't. If they did, there would be a massive hole in the earth under every large tree. No, trees are made of air. They breathe in carbon dioxide, and the sun comes down and uses its energy to rip the oxygen away from the carbon. That is a difficult thing to do. Oxygen and carbon want to be together. They want to hold hands tightly, but the sun forces them apart. The tree takes that carbon and builds its body, locking that solar energy inside the wood like a battery. And when you light the fire, you are just undoing the spell. You provide a little heat, just enough to let them jump the barrier, and snap, and the oxygen rushes back to the carbon. And in that violent reunion, all the energy that was stored is released. The light you see is the sunlight that shone on the forest decades ago. The heat you feel is the heat of a summer day from the past, and the force snapping them together? It is the same force, the same electromagnetic force that holds the magnet to your fridge. It is all one thing. Some people say that science takes the beauty away. They think that if you explain the rainbow, or the flower, or the magnet, if you break it down into equations and particles, it becomes dull. I do not agree. I think it adds to the beauty. Knowing that the fire in your hearth is actually ancient sunlight, knowing that the solid ground beneath your feet is just a frantic game of catch between invisible particles, that doesn't make the world less poetic. It makes it a miracle. It means that even a simple piece of iron is part of a grand universal dance. We have talked about the glue of the universe today. We talked about the electromagnetic force that holds the electrons to the atoms and the atoms to each other. It is the reason we have life. It is the reason we have structure. But we have only looked at the outside of the atom. Now, deep inside, in the center, there is something else. There is a nucleus. And if electricity is strong, what holds the nucleus together is something else entirely. It is a force that doesn't just snap, it burns. It is the force that makes the stars shine and the sun jiggle with such terrifying power. But why is the sun so hot? And how does it keep burning for billions of years without running out of fuel? That is a story about the nucleus. That is a different story. I'll leave you something to imagine.